Welcome back to All This Math. If you're here, hit the like button. If you're not already subscribed, hit the subscribe button, please. Also, if you got any questions as I go through my explanation of this problem behind this, please put your questions in the comments. Or if you got any comments, just put your comments in the comments. All right. Also, share this video with at least one other person. All right. At least one other person. All right. Now, I also want to give a shout out to Mission College. Right. Mission College is a historically black college, but it's fictional, right? It's a fictional historical black college. It's the college that they was at on the Spike Lee movie School Days. So if any of y'all are familiar, maybe some of the parents or grandparents that may be watching this, you know what I'm saying? Came out in the 1980s. Yeah, if you're a child watching this, yeah, this movie came out back in the 1900s, right? Last century, right? Since we're in 2025 right now as I record this video, right? But Mission College was the actual college that was featured in the movie School Days, which I think is a great movie. I recommend it I recommend it, you know, if you haven't seen it. All right. Um, let's get into this problem. Well, what are we doing today? We're dealing with arc length. Arc length, right? Arc length of a circle. Circles have arcs. The perimeter or the circumference of a circle, if you break it into smaller pieces, each of those pieces is an arc. If you envision like a circle is like a whole pizza pie, the arc would be the pizza crust. That's how I always remembered it. The arc is the pizza crust. That's it. Like, look at this right here. This is called a sector. This part is called a sector. That would be a slice of pizza. That'd be comparable to a slice of pizza, right? You got a slice, you got another slice, another slice, another slice, and another slice. Notice how these slices are not all equal size, right? This one is dumb big. This one is a little smaller, but still bigger than a typical pizza slice. These two look like they're the same size, right? This one might be, no, this one ain't as big as this. This is smaller than this one, right? But they all kind of, the sizes are all over the place. But anyway, the arcs are, you know, they go from points. So point C to point N to point H, that's an arc. Point H to point B, that's an arc, right? Point B to point M, that's another arc. But let's read the question though. The question says, or I should say the instructions. Let's read the instructions because there ain't no question mark, so it's not a question. But if the circle has a radius of 15 centimeters, find the arc length. And in this case, we're looking for arc HB. How do I know? Because that's an arc symbol. We see that little curved symbol right there over top of the two points. The name, because every point has a name, right? In this case, we're talking about the arc. We got to understand the language of mathematics, specifically the language of geometry, right? How to read it, speak it, and write it. So that this symbol means that we're looking for the arc, or we're dealing with the arc that goes from point H to point B on the circle. Here's point H, here's point B. So we're looking for this arc right here, the length of it, not the measure. Put that in your notes. Arc length is not the same thing as arc measure. Length is a type of measurement, but when we talk about arc measure, we're talking about a degree measurement, right? Because the whole circle is 360 degrees. So an arc measure is going to be a portion of that 360. All right. Now, I was intentional about picking the points that I picked, the letters that I use to represent these points, right? Because when you come to the All This Math YouTube channel, you get a 2-for-1. You're going to get a math lesson and you're going to get a little brief history lesson too. I'm going to put you on, right? So the NHB stands for Nanny Helen Burroughs. Black woman, educator in the DC area from Virginia, but grew up in DC, went to M Street School, which is currently today Dunbar, the Dunbar High School in DC, right? Very famous high school, right? She started an independent school. She started an independent school, which was, I want to say, it was in existence until the early 2000s, maybe 2006. Somebody closed down, but definitely do your research on Nanny Helen Burroughs. Nanny Helen Burroughs, and then I got MC right here. I went with the theme of black women that started independent schools. MC stands for Marva Collins. Marva Collins was an educator from Chicago who started an independent school out of her house, right? Independent school out of her house back in I want to say like the 1970s or the 1980s. All right. So we got Nanny Helen Burroughs. If you're not familiar with her, get familiar. And we got Marva Collins. If you're not familiar with Marva Collins, get familiar. There actually was a TV movie that came out in the 1980s about Marva Collins. You could probably find it on YouTube. I think I watched it on YouTube. It's called The Marva Collins Story. All right. I forget who played her husband. Some famous actor. It might have been Morgan Freeman. Was it Morgan Freeman that played her husband? I don't know. I need to go run that back. I need to go watch that movie again. But anyway, Nanny Helen Burroughs and Marva Collins, two people that we should understand. The center, I named it S because that stands for the word school, since they both were sisters that started independent schools. All right, now, if the circle has a radius of 15 centimeters, hold up, let's make sure you know what a radius is. I don't want to take that for granted. The radius is a length inside of a circle that goes from the center of a circle to the edge of the circle, or the circumference of the circle, right? This whole ring, many of us think of this as the actual circle, but the circle consists of the space inside as well. Well, this is the actual circle, right? But it encloses a certain amount of space. So if you want to define the area would consist of the space that's in between or inside of this circular ring, right? Which is the actual circle. All right. Now the radius goes from the center to the edge. So this will be a radius from point S to point B. This will be a radius from point S to point H. This will be a radius from point S to point N, and also from point S to point C, and from point S to point M. All right. Those are all, the plural is radii. You know, it's Latin. Radius is singular. Radii is plural. You know what I'm saying? All right. That's, you know, just a little detail I wanted to give you. Right. I did take Latin back in the day too. You know what I'm saying? But anyway, if the circle has a radius of 15 centimeters, find the arc length. All right. So in order to find arc length, you got to do this, right? You got to find the circumference of the whole circle. That's the first step. You got to find the circumference. Now, what is the circumference? The circumference is the length around the entire circle, from one point all the way around back to that point. It's like the basically the perimeter of the circle. That's what the circumference is, right? Triangles have a perimeter, squares have a perimeter, rectangles have a perimeter, trapezoids have a perimeter, a hexagon, you know, a septagon, a nonagon, they all got perimeters. But circles are so important, so exclusive, that they got their own word for their perimeter. Instead of just saying the perimeter of a circle, we say the circumference of a circle. All right. And it's a formula for it. It's a special formula that we can use to find the circumference of a circle, not to be confused with the formula for the area of a circle. So the circumference, we say capital C, is equal to 2 times pi times the radius. Or we say 2 pi r, right? In the math teaching business, we just say 2 pi r. We could also say pi d. Pi d stands for pi times the diameter. But we don't know the diameter. We know the radius. I mean, we could figure out the diameter by just multiplying the radius by 2, because the diameter is always going to be 2 times the radius, always. But since they give us the radius, let's just use this formula, 2 pi r. All right, so the first step, find the circumference of the circle. Now, why do we do that? Because the arc length is going to be a fraction of the entire circumference. Because like, remember what I said, an arc is like pizza crust. So we want to know the length from this point to that point. So first we got to figure out the length around the whole circle. And then we also know what the fraction of this is. But you know what I just realized? I realized I left out a piece of information. Let me check my notes. Yeah, definitely. I definitely did. I left out a piece of information on the diagram. This arc right here has a measure of 26 degrees. That's important. I'm going to show you why in a minute. All right, I'm going to show you why in 1 minute. That's 26 degrees. So arc CM has a measure of 26 degrees. Not a length, but a measure. It's got a measure of 26 degrees, right? So let's keep it going. Let's first find the circumference. So we got the number 2. Then we got pi, which we know is 3.14. If any of y'all ever celebrate Pi Day, you know Pi Day is March 14th, right? Because pi is rounded off to 2 decimal places as 3.14, right? And then we got the radius, which we're given was 15 centimeters, right? And we equal sign. And notice how I'm setting up my work, right? On your paper, you should set up your work nice and neat, right? In rows, neat rows. So you can see the progression. We started out with 2 pi r. Now we got 2 times 3.14 times 15. So that also indicates where these numbers came from. 3.14 replaced pi. 15 replaced r, right? Now we're going to multiply because this 2 times pi times r. So it's 2 times 3.14 times 15. All right. Now, what I'm going to do is I'm going to grab my calculator real quick. And I know it's going to be something like 90 something. And the reason I know that is because if I did 2 times 15, I would get 30. And then 30 times 3 is going to be 90. But it's 3.14, so it's going to be a little more than that. Or I could say 2 times 3 is 6. And then 6 times 15 is 90. But I know it's a little more than that because it's not 2 times 3. It's 2 times 3.14. But that's like, you know what I'm saying? That's something you should get in the habit of doing as you're doing math problems, right? You can use the calculator to confirm your answer, but we already know what we expect it to be, right? Just like you kind of estimate what your total going to be when you grocery shopping or something. When you get to the cash register, you should already know about how much you're spending, right? That's why, like, if you did the mental math, you like, yo, I think I'm about to spend $100, and then you get to the register and they ring you up for like 150. You're like, whoa, something ain't right. What's going on, right? Something might have been mislabeled or something, you know, or somebody might have messed up their math, or you might be getting overcharged, you know, for no reason. And then times 15, 94.2. Like I said, so the circumference of this circle is 94.2 centimeters, not squared, because area is squared, because area tells us how many squares are inside the circle, right? The circumference tells us the length around. It's almost like putting a belt on, right? What's the length around the body? What's the length around the circle? All right, so we got 94.2 centimeters. So we're going to use that. Now we got to figure out this. From point H to point B, that's the arc, right? What fraction of the circle is this arc? What fraction of the circle is this arc? How do I figure that out? This is how you figure that out. That's why this 26 degrees is important. And you also got to know this. You got to know something called the vertical angles theorem. Vertical angles theorem. This angle and this angle are called vertical angles. Vertical because they share a vertex and they're across from each other. And the line segments that create the angles form an X. So when you see like this X formation, you know you're dealing with vertical angles. So anyway, you see, even if you see it on some furniture in your crib somewhere, right? You know you're dealing with vertical angles. So that means if this angle is 26 degrees, then this angle got to be 26 degrees. And we know this angle is 26 degrees because if the arc measure is 26, then its central angle, and these are all geometry rules that I'm putting you on to, the central angle is also 26 degrees. So that's the central angle because the vertex is at the center of the circle. That's why we call it a central angle. So if the arc measures 26, the central angle is 26. And if this angle is 26, then that angle got to be 26. And if that angle is 26, then this arc over here got to be 26. So arc Nanny Helen from Nanny Helen Burroughs is 26 degrees, right? Now, how does that help us? We try to figure out the measure of this. We need to know, right? We need to know the measure of this so that way we can figure out the fraction that this arc is of the whole circle, because the whole circle is 360 degrees. So we got to figure out the arc measure of arc HB also. So arc HB, so if we know, all right, check this out. See this little box right here? This is a 90-degree symbol, right? So in this line right here from N to M, that's a diameter, right? The diameter cuts a circle in half. A whole circle is 360 degrees. What's half of 360? 180. So that means that from here to here is 180. So if that part from here to here is 90, what's left? From here to here got to be 90 also. From here to here got to be 90 also. So watch what I'm about to do. I put a right angle right there. Now make sure you understand why that makes sense. That makes sense because look, we already knew that was 90, right? This angle right here, this central angle is 90. If from here all the way around to here is 180, because that's half of a circle, it's a semicircle. The whole circle is 360. What's half of 360? 180. So that means this plus this plus this must be 180. That means these two central angles must add up to 180 minus 90. What's 180 take away 90? Take away this 90 right here, we left with 90. That means these two angles put together must be worth 90. Now, I want to find out the arc measure of this arc. So if I know that this is 26 and that's part of the 90, you got to do 90 minus 26. What's 90 take away 26? 90 take away 20 is 70. 70 take away 6 is 64. So that's 64 degrees. So that means the arc is 64 degrees. The arc measures 64 degrees. So that means that if the whole circle is 360 degrees, then the fraction that this arc represents is 64 out of 360. 64 out of 360. So that means this is how you find the arc length. You're going to take the circumference, 94.2, and multiply it by the fraction that this arc represents. This arc represents 64 out of the whole 360. The whole circle is 360. This arc is 64 degrees of that 360. So it's about 1/6, because 60 out of 360 is 1/6. So you're going to write that. 64 over 360, right? And then I'm going to do, let me see something. What I would do is I would simplify this. Even though I'm end up using a calculator anyway, I would simplify this and I would say, all right, well, I can reduce this fraction, meaning make the number smaller, reduce the value of each of the numbers, right? Even though the value of the fraction will stay the same, the value of the individual numbers, the numerator and denominator, will reduce. They will get smaller, right? We also call it simplifying because you're making the numbers smaller. You're changing the numbers into simpler numbers, right? So what's my common factor? My common factor is it 8? I could use 8. Let me see something. 360. You know what? Let's go by 2. Well, actually, no, let's go by 4. Let's go by 4. 4 is a common factor. Not the greatest, but it is a common factor. What's 64 divided by 4? That's 16. What's 360 divided by 4? That's 90, right? So now I got 16 over 90. Now, what if I just cut this in half? Because each of these are also divisible by 2. 16 and 90. 16 and 90, they're divisible by 2. So you got to know how to reduce fractions, right? For any level of math you go to, right? 16 divided by 2 is going to be 8. 90 divided by 2 is going to be 45, right? So now we got 94.2 times 8/45. So watch this. Watch what I do. I'm going to go over here with it. 94.2 times 8/45. Get rid of that equal sign because I'm not writing it over there. Go back to my calculator. Oh, it's in my pocket. So what I could do now, be careful. Do not, and I made a video about this yesterday called Popular Math Mistakes. Do not multiply this 94.2 by both of these numbers. That is wrong. We're not doing that, right? If 94.2 is represented as a fraction, you would have a 1 as a denominator. So we do 90, we go horizontal, 94.2 times 8 and 1 times 45. 94.2 times 8 and 1 times 45, right? So 94.2 times 8 is 753.6. And then we're going to take that product, divide it by 45. We get 16.74666. So 16.75, and it's the length. So we're talking about centimeters. 16.75 centimeters. And that's how you find the arc length. That's how you find the arc length. All right. And before anybody start talking about, oh, this too much, it's doing too much. Listen, whenever there's an explanation, the explanation is always going to take longer than when you're actually doing the problem. Like if I wasn't trying to explain how to do this, and I wasn't talking about, school days and Mission College and all that, and Nanny Helen Burroughs and giving out history lessons too. If I'm just sitting at a table as a student trying to get to the answer of this, I'd have banged this out in like 90 seconds. Real talk. I'd have banged it out in like 90 seconds. So that's the goal. You want to get to that point. Now you might have to watch the video that's long to figure out how to do that. But now when you practicing, and another thing you got to understand too, as you practice, you will get faster and faster, right? But don't let that discourage you. Don't think, oh, every time I do one of these problems, it's going to take 15 minutes. No, it's not. Calm down. All right. So look, the explanation is always going to take longer than when you're actually just doing it, attempting to try to get to the answer. All right. So don't let that be an excuse. Oh, he's still talking about this. It's take forever. No, it's taking forever because I'm trying to give you all the details because I already know what stumbling blocks you're gonna have. I already know. I've been in this game for a minute. I've been teaching for 20 years. I've been teaching this stuff for 20 years. I already know what the parts are to get students caught up. Right. So everything I say is for a reason. All right. So now answer 16.75 centimeters. So that means that out of the 94.2 centimeters all the way around the circle, this arc from point H to point B is 16.75 centimeters out of that 94.2 centimeters. All right. So again, quick recap. What's the steps for finding arc length? You want to find the arc length. You got to first find the circumference of the whole circle. Find the circumference of the whole circle. Then you got to know the arc measure because you use the arc measure to figure out what fraction that arc represents out of the whole circle. Right. That's where we got the 64 over 360 from. That's the fraction. The arc measure was 64. Now we had to do a little work to figure that out, right? Because they ain't get that to us. They ain't give it to us, so we had to figure it out, and that's cool. That's why this really is about problem solving. In life, you got to figure stuff out, right? You want to be one of the people that know how to figure stuff out, right? There's a lot of people that don't know how to figure stuff out. And that's not comfortable for me. I don't know if it's comfortable for you not knowing how to figure stuff out. You want to know how to figure stuff out. Bad things happen when you can't figure stuff out. All right. So look, so then you take the arc measure, which is 64. That's a fraction out of the whole measure of the measure of the circle, not the length, the whole measure, which is 360. All circles have a total angle measure of 360. And then you just multiply. Now you back in elementary school, just doing multiplication, right? You gotta bring them elementary school skills to the table when you're in a geometry class. All right, so this is arc length. This is how you do it. I think I'm gonna do another video with another example using this same circle too. You know what I'm saying? This video not gonna be as long though. But yeah, but if you ain't hit the like button, go ahead and hit the like button, right? Subscribe if you didn't subscribe yet. Share this video with somebody, right? This is top tier teaching. I'm trying to tell you. This is top tier teaching, right? Share this video with somebody and drop a comment in the comment section if you got a comment, right? Or if you got a question, if something is still unclear to you, put your question in the comment section. All right. See y'all later. Peace.